Next, we're going to be taking a look at antiderivatives of transcendental functions, which includes both exponential and logarithmic. For our first example, we're going to do exponential. Rule number 17 in our series of antiderivative rules is very easy. We know the derivative of e to the x is just e to the x, so it makes sense that the antiderivative of e to the x would also be e to the x. Don't forget the plus c. How about the antiderivative of a base other than e, say a to the x? So let's just say a was 3. Okay, we'll look at the application in a second. So anyway, antiderivative of a to the x is a to the x over natural log of a plus c. For example, if this was 3 to the x, it'd be 3 to the x over natural log of 3 plus c. Again, you can verify that by taking the derivative of this. You will get 3 to the x back. Go back through and look at your rules for the derivative of a to the x, and you'll see that when you take the derivative of this, you get 3 to the x back. Rule number 19, antiderivative of natural log of x, is x ln of x minus x plus c. Now, I've actually seen this one come up more often than I thought, so make sure you learn this one. And again, if you take the derivative of x ln of x minus x plus c, you will just get natural log of x back. Number 20, antiderivative of log base a of x, so a base other than e, is x ln of x minus x over natural log of a. So it's basically the same as 19. You just divide by natural log of a. And again, the reason that works out is because when you take the derivative of this, you will get log base a of x back. So for an example, just say it's log base 10. It'd be x ln of x minus x over natural log of 10. Okay, where a is 10, your base. So these are your rules for exponential functions and logarithmic functions. Let's take a look at an example. We have antiderivative of 3 to the x minus cosine of x over 4 dx. Again, the reason I'm giving you some more complicated ones is because a lot of times you've got to simplify first. I mean, to me, it's not enough just to look at a table of antiderivatives and be able to say, oh yeah, antiderivative of cosine is sine. Well, of course, that's very easy. So let's do something that requires a little bit of application. Step 1, we want to convert this to anti-differentiable form like we've been doing for the other ones. Quickly, you can see that dividing by constant, you can just move it out front and make it 1 over 4. So now it's 1/4 antiderivative of 3 to the x minus cosine of x. We can then split that up into two different antiderivatives. Like I said before, antiderivative of cosine is sine. Antiderivative of 3 to the x we just talked about. We will be using this rule up here. So it'll be 3 to the x over natural log of 3 plus c. Now we can antidifferentiate. As I just said, leave this 1/4 out front, so it's a constant multiplied by 3 to the x over natural log of 3 minus sine of x plus c. We can simplify that by distributing the 1/4 back into each of those terms. Now this is important. You might be thinking, what about the 1/4 in the c? Well, 1/4 times c is still a constant, right? Plus c means constant. So you're going to see that a lot as you move through calculus. Whenever you operate on a constant, it's still just a constant. So you don't have to put the 1/4 c, because that's still just c. And then we can easily check that by differentiating. A lot of times I just check this step off, because what I do is I kind of just go backwards. And so I will just look at this and say, okay, what's the derivative of this? Okay, well, it actually, if I take the derivative of this, it'll give me 3 to the x. If I take the derivative of this, it'll give me cosine, right? And then I'll still have the 1/4 when I take the derivative of that. And then I can just distribute that 1/4 back into both of those. So you can mentally do that. You're going to find that when you take an exam, a lot of times in calculus, you have a limited amount of time. So you're not always going to have time to check your work. Sometimes you just have to go back through it. That's it for example 4 of an antiderivative of an exponential function and its application. If you have any other questions about this, let me know.